Good day to everyone. Unit 1 will be the first topic of AC 1103 and it is entitled An Introduction to Management Science. I will cut the video of Unit 1 into two parts so that the lecture won't be too long. Let us now proceed with Part 1 for Unit 1. We may be curious, why should we, as accounting students, study management science? We need to realize that decision-making is an integral part of our daily lives. We make decisions every day. Some decisions are quite simple and can be made fairly quickly. For example, what to wear. However, some situations are more complicated and important that they need more careful consideration before a decision is made. For example, in business. And that is the main reason why it is important to study management science. Because managers should not be making decisions just out of their whims. Rather, whatever decisions they make need to be supported by management science techniques. The credibility of these techniques is strengthened by the fact that the scientific method is used as the basis in the development of analytical methods and quantitative techniques to aid managers in making complex decisions. Management science is also known by other names such as operations research and decision science. Most recently, it is known as business analytics. The need for it stemmed from the World War II, where the military had to deal with strategic and tactical problems. After the war, concepts of management science were applied in business because, in essence, when one engages in business, one is fighting a battle to earn profits and compete with other companies in the same industry. It was Frederick W. Taylor who initiated the scientific management revolution in the early 1900s, and its use in today's world has become more meaningful, especially that we can now use computers to make complex mathematical computations and help us make decisions based on those computations. There are two techniques or methods of decision making. We can use qualitative techniques or quantitative techniques. Qualitative techniques are subjective by nature, which means that decisions are made based on or influenced by personal feelings, tastes, and opinions. On the other hand, quantitative techniques are objective by nature, which means that decisions are not influenced by personal feelings or opinions in considering and representing facts. Once you have your input information, you analyze qualitative and quantitative material differently. For qualitative information, such as interview transcripts, texts, and pictures, you have to study the material to get insights about what it means. If you want to judge how positively your customers feel about a product, you have to analyze what they say carefully, paying attention to the positive words they use. Your analysis results in qualitative judgment, such as your conclusion that most customers like your product very much. These are information that are not easily measurable and difficult to express in numbers. On the other hand, quantitative analysis relies on statistical methods and mathematical evaluation. For example, you can calculate what percentage of customers experience problems with a product, what percentage plan to buy another product, and how many will recommend the product. You can use that information to conclude how many products you are likely to sell. The results of your qualitative analysis often are ambiguous. but they may contain additional information. For example, your customer interviews might indicate that customers liked your product, but would appreciate faster deliveries. On the other hand, your quantitative analysis has no extra information such as that because it is focused narrowly on a particular characteristic, such as customer satisfaction. The different outputs of your analysis lets you use the qualitative output to check what the quantitative data says and to keep the extra information for additional action. So which technique should we do to make a decision? It is important to combine your analysis of both qualitative and quantitative information because it helps you make the appropriate decision. For example, you may have analyzed how much your customers like a product, so you can decide whether to increase production. You may find from your customer interviews that customers like the product, and your quantitative analysis may indicate that, for example, 75% of customers would purchase the product again or recommend it. Therefore, you can use the quantitative result to justify increasing production since it reinforces the qualitative result. However, in the event that the two methods produced different results, you would need to do more analysis. Enumerated herein are examples of qualitative methods of decision making. We have SWOT analysis, which stands for strength, weaknesses, opportunities, and threats. Another example is the PEST analysis. PEST stands for political, economic, social, and technological. Public image is also a qualitative method of looking at how successful a company is. And the last example given is long-term survival analysis by analyzing employees, shareholders, managers, the environment, the local community, suppliers, the government, and consumers. Examples of quantitative methods are investment appraisal, break-even analysis, market research, measures of correlation, forecasting, decision analysis, linear programming, and PERT CPM. The types of managerial decisions are differentiated in three ways. We have personal versus organizational, routine versus non-routine, and program versus non-program. Personal decisions are decisions that a person takes in his own capacity and are not delegated to others. For example, if a manager decides to resign, he is making a personal decision. On the other hand, organizational decisions are taken by a manager in his official capacity and can be delegated to others. For example, if the manager is on leave, he can ask someone else to attend a meeting on his behalf. These decisions directly affect organizational behavior. Next, routine decisions are those that are made repetitively, which require little to no deliberation, such as hiring a new employee when an existing one resigns, while non-routine decisions relate to unique or one-time decisions involving large investments or expenditures of funds. An example of this is an investment in a new building costing 100 million pesos. Routine and non-routine decisions, taken together, play a very important role in the success of an organization. Lastly, program decisions are the decisions that are handled through standard procedures. For example, if an employee commits theft, the consequences for the offending employee is automatic dismissal. Guidelines for program decisions are usually written in the company's manual. Non-program decisions, akin to non-routine decisions, are unique, not indicated in the company manual, and these are made by managers using available information, experience, and professional judgment. Regarding decision-making models, we will discuss three. We have the econologic or economic man model, bounded rationality or administrative man model, and implicit favorite or gamesman model. The first model is the econologic model. It assumes that people are economically rational and people attempt to maximize outcomes in an orderly and sequential process. Economic rationality is a basic concept in many models of decision making. It exists when people attempt to maximize objectively measured advantages, such as money or units of goods produced. This model assumes that people will choose the decision or course of action that has the greatest advantage or payoff from among the many alternatives. It is also assumed that they go about this search in a planned, orderly, and logical fashion. If we look at the steps involved in the econologic model, notice that the model develops all alternatives and determines all outcomes. This means that if we use this model, it will take up too much time before a decision can be made, especially if there are so many alternatives to choose from. If there are too many alternatives to choose from, then the econologic model is probably not the best model to use for decisions that need to be made in a timely manner. The second model is the bounded rationality model. This model does not assume individual rationality in the decision process. Instead, it assumes that people, while they may seek the best solution, usually settle for much less because the decisions that they make typically demand greater information processing capabilities than they possess. They seek a kind of bounded or limited rationality in decisions. Another assumption is that people examine possible solutions to a problem sequentially, which means that rather than identifying all possible solutions and selecting the best as what the previous model is doing, it only seeks to satisfy. For example, if alternative 1 is already acceptable, then that will be the decision taken, and we do not attempt to seek out other alternatives. We only consider other alternatives if the first alternative is unacceptable. Notice that this model employs heuristic programs. A heuristic technique, often simply called a heuristic, is any approach to problem solving or self-discovery that employs a practical method not guaranteed to be optimal, perfect, or rational, but instead sufficient for reaching an immediate goal. Therefore, this model is called a satisfier. The third model is the implicit favorite model developed by Soilberg in 1967. He made a study and found out that people are biased towards their favorite choices. In his study, he observed the job choice process of graduating business students and found out that in many cases, students already identified implicit favorites early in the recruiting and choice process. However, they continued their search for additional alternatives and quickly selected the best alternative candidate, which is called the confirmation candidate. Next, the students attempted to develop decision rules that shows that the implicit favorite was superior to the alternative confirmation candidate. This was done through perceptual distortion of information about the two alternatives and through weighing systems designed to highlight the positive features of the implicit favorite. Finally, after a decision rule was derived that clearly favored the implicit favorite, the decision was announced. Ironically, Swelberg noted that the implicit favorite was typically superior to the confirmation candidate only on a few dimensions. Even so, the decision makers generally characterize their decision rules as being multidimensional in nature. Let us illustrate the implicit favorite model in a real-life scenario. Assume that as early as now, you imagine yourself that you're going to work in BDO after becoming a CPA. BDO is referred to as your implicit favorite. Now, after graduating and after becoming a CPA, even though you really want to work in BDO, you still look for other alternatives. So let us say your other alternatives are Ayala, Metrobank, and SGV. Now, from among the other three, let's say you reject Ayala and Metrobank. So SGV is what we call the confirmation candidate. You then list down the pros and cons of working in BDO and SGV. So let's say working in BDO entails bonuses, but then low salary and no opportunities abroad. And let us assume working in SGV entails high salary, opportunities abroad, but then long office hours. Even if it is obvious that SGV is a better career choice compared to BDO, you still end up choosing BDO by justifying that bonuses is more important to you than high salary or opportunities abroad. Because you are biased towards working in BDO. So that illustrates the implicit favorite model. Knowing that life is all about facing problems and making decisions, realize that someday you may have to work in an environment that requires you to make important decisions for the company. The problem-solving process involves three logical divisions, which are structure, analyze, and manage. Structure means to construct or arrange according to a plan, give a pattern or organization to. Analyze means to examine methodically and in detail the constitution or structure of something, especially information, typically for purposes of explanation and interpretation. Manage means to supervise and oversee. The problem-solving process involves 7 steps. The first 3 steps in red font pertain to structure. The fourth and fifth steps in blue font pertain to analysis, while the sixth and seventh steps in green pertain to management. The first step is to define the problem. This is often where people struggle because they react to what they think the problem is, instead of seeking to understand more about why you think there's a problem. Second step is to determine the set of alternative solutions in order to solve the problem. Third is to determine what should be the criteria used to assess the available alternatives. The fourth step is to evaluate the alternatives using both quantitative and qualitative data and based on the criteria set forth in the third step. The fifth step is to choose an alternative, and it is the step where the decision has to be made. The sixth step is to implement the selected alternative, and for the seventh and the last step, the results of the decision should be evaluated to see if the problem has been satisfactorily solved. Although the terms problem solving and decision making are sometimes used interchangeably, management literature makes a clear distinction between the two. Problem solving is a larger process that starts with the identification of a problem and ends with an evaluation of the effectiveness of the chosen solution. Decision-making is just a subset of the problem-solving process and refers only to the first 5 steps of the problem-solving process. The decision-making process may involve single criterion or multi-criteria problems. As their name suggests, single criterion decision problems refers to those problems whose objective is to find the best solution considering only one criterion, while multi-criteria decision problems involve more than one criteria. Going back to the decision-making process, which consists of 5 steps compared to the 7 steps of the problem-solving process, note that it consists of structuring the problem, after which, when the problem is already well organized, then it is time to analyze the problem. In the analysis phase, we can do either qualitative or quantitative analysis. Qualitative analysis entails professional judgment and experience, and since the manager bases his decision on feelings rather than numerical details, it is considered as an art rather than science. When quantitative analysis is done, managers translate objectives, constraints, and other relationships into mathematical expressions. Quantitative procedures are done in order to provide a numerical basis in making decisions. This slide shows the role of quantitative and qualitative analysis in the decision-making process. Although skills in qualitative analysis may be inherent in the manager, for example, he has good business sense obtained through his years of experience, quantitative analysis can be learned only by studying management science. A manager can increase decision-making effectiveness by learning more about quantitative approaches and how it contributes to the decision-making process. A manager who is knowledgeable in quantitative decision-making procedures becomes more competent in comparing and evaluating the qualitative and quantitative sources of recommendations and ultimately to combine the two sources in order to make the best possible decision. Now that we're done discussing about the decision-making process, I would like you to answer this graded discussion. This will be done by group, and each group will have a maximum of 6 members. This is already embedded in your Canvas discussion board, and it is due on September 3, 2020 by 10 p.m. for everyone. The problem that we aim to solve is, I need to pass AC 1103. So you are required to give 5 alternative solutions that can be undertaken to ensure that you can pass the subject. Then, determine 3 criteria used to evaluate the 5 alternative solutions. Then, you need to evaluate the alternatives by giving pros and cons to each alternative. Ask the question, is it risky? Is it worth it? Is it effective based on past experience? Then, choose an alternative. Give the reason why you choose this alternative in order to pass AC 1103. We know that the focus of our subject, AC 1103, is to study the quantitative approaches rather than qualitative approaches. We need to know what are the potential reasons of applying the quantitative analysis approach to decision making. First is if the problem is complex. This occurs when the problem is too complicated that you cannot make a decision out of nowhere because it might lead to a wrong judgment. It is important to note that quantitative analysis is not an assurance of making the right decision. However, the risks are somehow lessened as doing so would give you a rational basis as to why you are making such a decision. Second is if the problem is very important. Employing quantitative techniques requires a lot of time, effort, and funds. If the issue involved is not important, then it might be better to forego it, as doing so may have very high costs and may outweigh the benefits. Third is if the problem is new. When the problem is new, you still do not have the experience and expertise to make a decision without a known basis. Lastly is if the problem is repetitive. It may be beneficial to develop a mathematical system for issues that keep on repeating so you can use it in a business day-to-day activities rather than waste time to look for solutions for a problem that can be solved using a single model. The quantitative analysis process comprises of model development, data preparation, model solution, and report generation. Let us talk about model development first. In reality, it is impossible to make perfect decisions because we need to consider timeliness, completeness, and reliability. For timeliness, the more time we take to consider a problem, the more likely we can make the right decision. But if we keep waiting, it may already be too late to decide. Regarding completeness, even if we want to know everything pertaining to a problem, it is impossible to do so because there are always factors that are not known to us. Lastly, not all information we obtain are reliable. Some information that we need may not be available. And because of this limitation, we can only make estimates. So that's the reason why we need models. So what are models? Models are representations of real objects or situations, but they are just approximations or estimates of reality. So we cannot expect that the models resemble real situations 100%. Therefore, we can infer that all models are wrong, but some are useful. All models are used to approximate reality, but how effective they are depends on how reliable are the inputs. This follows the principle of GIGO. GIGO means garbage in, garbage out. If the inputs are useless or garbage, then expect that the output will also be useless. There are three types of models: iconic, analog, and mathematical. Iconic models are physical replicas or scalar representations of real models. Iconic models are also known as actual models. An example of an iconic model is a model airplane. A model airplane looks exactly like a real airplane, but in a smaller scale. Second are analog models. These are physical in form, but do not physically resemble the object being modeled. An example is if you draw a heart, you know it is a heart, but it does not look like a real heart. Third are mathematical models. They represent real-world problems through a system of mathematical formulas and expressions based on key assumptions, estimates, or statistical analysis. A simple example is the computation for total cost. So total cost is equal to variable cost plus fixed cost. So if your variable cost is 10,000 pesos and your fixed cost is 30,000 pesos, then your total cost would be 40,000 pesos, which represent the total cost. Even though models may not be 100% accurate, there are several advantages of models. If we experiment with models compared to experimenting with the actual situation, it requires less time, is less expensive, and involves less risk. For example, it is easier, faster, and cheaper to first build a model airplane than building an actual airplane. Moreover, if you make a mistake in building the model airplane, then there is not much risk involved. It is easier to make modifications in the model airplane. But if you build the real airplane straight away and find out that you made a mistake later on, then modification costs would already be sky high. Finally, the closer the model represents the real situation, the more accurate the predictions will be. It is therefore important to make an effort to reasonably assure that the model really does epitomize the actual scenario. In AC 1103, we will focus on constructing mathematical models. We need to look at the four elements of mathematical models and translate these into mathematical expressions. These four are objective function, constraints, uncontrollable inputs, and decision variables. When choosing a model, we need to consider not only the benefits, but also the costs. Because in many instances, a model that is simpler and maybe less accurate is more suitable to solve a certain problem because it is easier and cheaper to implement. The first element of a mathematical model is the objective function. We need to know what is the objective. Since in business, our goal is to obtain profits. The problem's objective is either the maximization of profit or minimization of costs. The second element are the constraints. These are a set of restrictions or limitations. An example of a constraint is production capacity. Even though we want to produce 100,000 units of product X per week, for example, we cannot achieve this if our machines are not capable of doing so. Other good examples of constraints are time and money. We need to recognize that these resources are constraints because they are scarce. we only have a certain number of operating hours per day, and our monetary resources are not infinite. The third element is uncontrollable inputs. These are factors which the decision maker cannot control. For example, we have normal and expedited activity completion times. Even if we want to construct a building in a week, we would not be able to do so because certain processes need time to finish. Similarly, uncontrollable events such as today's pandemic may also hinder our efforts to complete a certain project. Activity expediting costs may also be beyond our control. It would depend on how much the contractor will charge. Next, even if we want to have a project expedited, we may not have enough funds available to speed up the project. Lastly, we have precedence relationship of the activities. If a certain project requires, let's say, 10 activities before it can be completed, and it gets stuck up in, let's say, activity 5, then we cannot complete the project. The last element is decision variables. These are inputs controllable by the decision maker. An example of this is how many units of a certain product the manager wants to produce. He can decide to produce 10 units or 100 units, but of course, subject to certain constraints. This slide shows the flowchart of transforming model inputs into output. We gather the uncontrollable inputs and controllable inputs and translate them into the mathematical model. Process it to produce an output or projected results. Now, let us try to construct a mathematical model where we will be tasked to identify the objective function, constraints, uncontrollable inputs, and decision variable. The problem states that you can earn a profit of $10 per unit sold, and we also have 5 hours which are required to produce each unit, and 40 production hours available per week. We are tasked to identify the objective function, constraints, uncontrollable inputs, and decision variables. We let x be equal to the number of units. Now, for the first requirement, which is the objective function, we have learned in the previous discussion that the objective would either be a maximization problem or a minimization problem. But in this case, since what is given is profit, then it is obviously a profit maximization problem. So to write down your objective function, that would be max 10x. Max stands for maximize, and 10 stands for the profit per unit sold. The second requirement is to identify the constraints. So this is actually a linear programming problem. And every time that we write a constraint, we should write down also subject to. So the first constraint would be regarding the time involved. So that would be 5x should be less than or equal to 40. Now, why is it that it should be 5x should be less than or equal to 40? Simply because we only have 40 production hours available per week. So the total time that we spend to manufacture these units should not exceed or should not be greater than 40. There is another constraint that we should include, but it is not obvious in the problem. And we call that the non-negativity constraint, which we write down as x should be greater than or equal to 0. Now, the reason why we should include x should be greater than or equal to 0 is because if we're going to produce a certain number of units, it could only either be positive or 0. Positive if we do produce a certain number of units, and 0 if we decide not to produce anything at all. But we cannot produce a negative number of units. So that's why we have to include that as part of our constraint. So third requirement is to identify the uncontrollable inputs. So in this problem, we actually have three uncontrollable inputs. First is the profit of $10 per unit sold. The second uncontrollable input is the 5 hours required to produce each unit. And the third one is the 40 production hours per week. The last requirement, we need to identify the decision variable. So to simplify matters, we look at the first constraint, which is 5x should be less than or equal to 40. So we just get rid of the less than sign and make it as equal sign. So if 5x is equal to 40, solve for x would be equal to 8. So this means that it is beyond our control to decide how many units to produce as long as it meets the two constraints. 5x is less than or equal to 40 and x is greater than or equal to 0. So that means we can produce 8 units or less, but we cannot produce more than 8 units because let's say, for example, we want to produce 9 units. So to substitute it with the first constraint, so 5 times 9, that would already be equal to 45, and 45 is greater than 40. So it is not actually a feasible solution. So your decision variable would be to produce 8 units or less. But in reality, since it's a maximization problem, why would we want to produce any units less than 8? If we produce less than 8 units, then we would have lesser profits. So to recap, the answers to this problem would be, number 1, the objective function is to maximize or max 10x. The constraints are, first, 5x should be less than or equal to 40, and x should be greater than or equal to 0. Number 3, the uncontrollable inputs are profit of $10 per unit sold, 5 hours required to produce each unit, and 40 production hours available per week. And lastly, the decision variable would be x is equal to 8 in order to maximize profit. This slide shows to us again the flowchart of transforming modal inputs into output. The uncontrollable inputs are the $10 profit per unit, the 5 hours production time per unit, and 40 production hours capacity per week. For the controllable input, we have x is equal to 8. So we are going to combine the uncontrollable and controllable input and come up with a mathematical model. So recall that the objective function is max 10x. So 10, we are going to substitute x with 8. Subject to, so we're going to test the constraint. 5 times 8, is it less than or equal to 40? Well, it is equal to 40, so it meets the first constraint. And secondly, x or 8 is greater than or equal to 0. So all the constraints are met, and this is a feasible solution. So for the output, After processing it using the mathematical model, 10 times 8 is 80. So we would have a total profit of $80, and the time used to manufacture the product would be 40 hours, which is computed as 5 times 8. Thus, in mathematical models, we need to relate the controllable inputs to the uncontrollable inputs, seek out to solve the objective of maximization or minimization. And we also need to recognize that models can either be stochastic or deterministic. If any of the uncontrollable inputs are uncertain or keeps on changing or unpredictable, so for example, the price of the supplier may constantly change, then we call that stochastic. However, if the uncontrollable inputs are reasonably certain or are predictable, then it is considered as a deterministic model. An example of this is tax rate, because tax rates do not constantly change. Certainly, it is easier to analyze deterministic models compared to stochastic models because deterministic models are predictable. In the previous problem that we just solved, we were told that a unit can be produced in 5 hours. This is considered as deterministic because we are given a value, 5 hours. However, if the facts change and production time per unit becomes ranging from 3 to 6 hours, then it becomes stochastic and the analysis will become more complex. The optimal solution for the model will then be the values of the decision variables that result to the mathematically best output, for example, the maximum profit or the minimum cost. This is the end of part 1. Please take a few moments to stretch for a bit before proceeding to part 2. When you're ready, please watch part 2 of Unit 1, Introduction to Management Science.